Hello, I'm Keegan Paisley. I'm a now graduated member of the Computer Support Specialist and Network and System Administration programs. And I'm going to talk a little bit about the environment that Levi Broderick and I set up for our Capstone project. So we decided that we wanted to build a managed service provider kind of solution for small businesses that needed a uh, managed hardware infrastructure. And we would accomplish that by remotely or on site managing their on prem server and Active Directory infrastructure, as well as their network. So, as far as like physical equipment goes, we have our server that was provided to us by Crystal Group, and we've got a switch, and we've got a laptop, and this additional laptop is kind of acting as our actual gateway to the internet, which is required for a couple of the things that we use in our environment. Um, so, just talking about the switch that we've got set up, we changed a handful of the VLANs. So, we moved everything out of the default VLAN of one. That's just best practice. And we created this VLAN 2, which we use for our gateway, and that is the connection between the laptop and the actual ESXi server. So those are on port 23 and 24, as you can see. And that's what gives our environment actual internet access, despite being on a different host and not having a wireless interface card. So we've also got this management network that we've got set up, or the management VLAN. We've got it set on port 28, so whatever would be connecting through port 28 would be considered part of the management VLAN. 1, 2, and 3 we put into this software developer endpoints. So anything that would be our software developer endpoints, which would be the laptops that our example organization were using, they'd be plugged in through that. And then we put all of the ports that are not in use into this 95 no trunk VLAN, specifically to shut them down and make sure that they didn't automatically negotiate trunking. And you can see that in here we went through, and all of these are in access mode, and they're set into their specific VLANs. And then for if we did decide to set up like something like OSPF or a spanning tree, and we would use trunking, then we'd set that on the relevant ports, but everything else would be in switch port mode access and accessing a specific VLAN. And VLAN 95 is just kind of our catch-all VLAN for doing nothing and being off. So let's talk a little bit about everything else in our environment. So we're going to come over here to our domain controller, and we're going to get to see my wonderful giant password for our administrator account. If I was clicked in and typing. So the first thing that we're going to look at is DNS. It's one of the first things that you should set up when you're handling a new Active Directory domain. We've got this Windows 10 Pro client, which is just like a example client that we set up to help manage all of our different solutions. And we've got our Active Directory domain using this 192.168.0 network for everything that we're doing. And then we set up DHCP. That way, when the laptops for our client would be connecting, they just pull a DHCP address. You can see we've got this pool set. It's relatively small. That gives us a lot of space in the front to set reservations. for specific appliances should we need to, or specific servers. After all, it's a software development organization that we pretended to be working with. They might have a lot of dedicated IP address space that they need for their solutions. So the next thing that we're going to look at is a bit of the structure. We've got a bunch of non-standard organizational units here. Specifically, we've got this issued employee laptops, which we've put Windows 10 Pro Client into, and then a bunch of example computer accounts. These don't actually exist in our environment. They exist just to prove the concept. We've got service accounts here and a managed service account group. So we'll talk a little bit about this later. And then we've got our workforce users. This is just to help keep it separate from the default users OU for ease of administration. So all of our developers and the developers group are in here. Management with the CEO, the network administrator with our network administrators group. And then specifically, we've got this TheoNet, who is also our network administrator. They have an unprivileged user account as well. That way, when they are performing non-administrative tasks, they sign out from their administrative account and log into their regular account. So if TheoNet was just browsing their email, they would simply do so through this unprivileged account instead of their admin account. And that's just a security best practice thing. So the next thing we're going to look at is our organizational structure for group policies. So we've got a pretty robust GPO environment. As you can see, we've got this CIS hardening recommendations. So we went through and made a lot of changes based on recommendations from CENTERNET for Internet Security's benchmarks, CIS benchmarks for Server 22, and applied that at a group policy level, so that would get pushed out to every computer in the network that is domain joined. So if we wanted to see a bunch of the things that were changed, we could go into here and look at all of these changes. But these are all just suggestions from CIS benchmarks. If you wanted to, you could look that up and see all of the changes. I didn't go through and change 100% of everything that was recommended by the CIS benchmarks. There were a handful of items that I considered either out of scope or our client organization column atmosphere would want to have that enabled regardless of the benchmark. So for example, CIS benchmarks recommends disabling IPv6. However, for the purpose of internal testing and some of the applications that column atmosphere develops, they require IPv6 to be used, so we didn't implement that. We've got a handful of other policies that had some changes made. Most of them were through additional CIS recommendations. We enabled the firewall locally, and then we've got some app locker policy, a logon script, and a Windows Update policy. Now, many of these, especially the ones that are just unlisted and not actually connected to anything, are more of a proof of concept, less proof of concept and more just showing what you could do with group policy. Their name is very prescriptive, so you can tell that this app locker policy has to do with the app locker functionality, which would prevent apps from running based on where they are or what their hash is, or only allow apps to run from a specific trusted location or with a specific trusted hash. And the reason that these exist is just, again, to prove that we understand how these work and know that we can change them. We'd offer, in a true solution, a lot more explanation on what each of these does, why they're applied to a specific location. And that's just so that it would enable more ease of administration in the event that either we as an organization had to hand off administration back to our client company, or if we have a handoff internally where the person handling the account is different. The next thing that we handled is password settings enabled through Active Directory Admin Center. The way that password policies work by default is you can only apply one, and it's through the default domain policy. However, if you handle your password settings through Active Directory Admin Center, you can actually apply different password policies to different groups. So if we look at this standard password policy and we look at the properties of it, we can see how it applies to different individuals and different groups within here. And then we can actually see, this is what I intended to show. We can see the groups that this password policy applies to. We have a minimum characters of 14. They only have to change their password every 364 days. That's by recommendation of both NIST and CIS for security purposes. So developers, domain users, and our quality assurance groups have this password policy applied to them. And then if we look at our privileged accounts, they actually have a password min length of 24 and have to change their password every 180 days. However, we can actually specify that they don't need to have special characters and such within their password, but we can set up a list of things to check against, making sure they're not using, standard dictionary words, password 01, stuff like that. And then when we look at our service account password, this is what services would authenticate as. So this is not something that a human would ever be typing. It's just, let's say we've got a logon script that needs to perform a specific action whenever a user logs into a system. So whenever the user logs in, this script would run, but because a human never needs to type this and it probably has a very specific set of permissions, it has a password length of 24 characters. And because or rather 64 characters, once again, because a human's never actually typing this. So let's move on to our pfSense. So I'm going to log in again to our wonderful administrator account. And the reason that we're logging in with the administrator account is because all of these computers have like a specific user that they are assigned that is allowed to log into them. And the only person who can bypass that is a domain admin. Otherwise, most accounts aren't allowed to log on locally. So as an example, if I switch users here, we have a little pop-up that says, make sure you read our acceptable use policy. And you can see that the sign-in method isn't allowed. So we'd have to log in with the admin account and, once again, our wonderful long password. So for pfSense, the first step is to actually have a separate VM here configured with the upstream gateway, which is set to the laptop that I was talking about earlier, and the LAN gateway, which is itself. So you set the LAN gateway to whatever IP you want to assign to pfSense, and then you set the upstream gateway to whatever is actually providing internet connection. pfSense acts as an in-between for them and filters based on your firewall rules. So we just have a couple of example rules in here, blocking insecure LDAP requests, blocking external RDP, and blocking external ICMP requests. And that's on our LAN port, which would be internet coming into our network. And then on the actual LAN side, there's the default anti-lockout rule that can't be changed on pfSense. And then we're blocking access to .10, which is our Active Directory box, just as an example. So this is blocking access to an admin portal over HTTP. So that would help reinforce the requirement for HTTPS and prevent a internal threat actor from attempting to force HTTP. And then we're also blocking RDP internally so that a threat actor who got into the network wouldn't be able to just jump around freely using RDP if they were able to get in. The next thing that we have to look at here is WASA. So WASA is a SIEM, or a System Information and Event Monitoring tool. So what it does is it deploys agents to all of our systems and endpoints. So as you can see, once it loads, we've got 4 agents that have been deployed to WASA, or from WASA, and it just monitors logs and things here. You can see we've got a couple of authentication failures from me earlier mistyping the giant password for our administrator account. We can see the different items and how many alerts they're throwing. This actually links these items with a MITRE ID, so a MITRE technique, through the attack framework. That's a wonderful thing to look at, and I highly recommend looking at that some more. The last thing that I have to show here is our AdGuard. So AdGuard is a DNS sinkhole, or a DNS black hole. And we just kind of set this up bare bones for the purpose of this. And because we actually wanted to communicate out of our internal network and use Kirkwood's DNS to actually resolve things that are external, we couldn't really use this internally. But what we'd do is we'd simply set this up as one of the DNS providers, this IP address. And then whenever a host within our network tried to resolve any domains that are a part of this list here, it would just get blocked, and it would dump it into an alert on the dashboard. One of the last things that we did was we set up endpoint detection and response. So EDR is another just like layered option that we decided to implement. And we deployed agents to these, and these EDR agents can actually prevent malicious actions from taking place, as defined by either the base instruction set that exists, for this case, OpenEDR, or whatever endpoint protection you have available. I can't actually access a lot of the events for this because the farthest back that this historically goes is a week, and I don't want to spend a whole lot of time throwing a whole bunch of errors only for one of them to get blocked, maybe. But this is just the OpenEDR platform, and we can check our different assets in here. And you can see that my license is about to expire. But we've got EDR, an additional firewall, antivirus going on both of these devices. So that is the bulk of our environment. The last thing that we decided to do was set up a website through Wix. We put our faces, our names, email, LinkedIn, and we put our resumes on here. and just a bit about our organization. So we put information here and to help anybody who was watching the presentation, if they missed something or didn't quite understand what we were saying, we could refer them back to this page, and that would help explain some of our services. But that's all I've got. Thank you very much, and good luck with your capstone project.